Okay, we're going to look at some of the review problems for test 3. Just so you know, I don't know if I have time to go over this whole review, but I wanted to at least do some. And I think what I might do is go ahead and work through what I consider to be some of the easier problems that don't take us long and still count equally on the test, and then save time at the end for the longer problems in case we run out of time. So we're going to go pretty fast because I don't have a lot of time. Matter of fact, I'm going to start with some of the vector problems. Number 11. They give us this vector. The magnitude of the vector u is 7, and they say the angle is 85 degrees. So let's talk about vectors. There are really 3 different ways that we can define vectors. Let me do a quick example. Say I have a vector v. One of the ways is with these pointy brackets. The vector 2, 3. Once again, a vector has both a magnitude and a direction. We normally like to graph vectors. So in this form, basically the 2 represents the x direction and the 3 represents the y direction. Basically, I go to my graph and I plot the point 2, 3, and that becomes my vector. So here's 2, 3. There's vector v. However, there's a second way they like to denote vectors, and that's by using this I and j. And it's very simple to see from this notation. The I is like the x part of it plus 3j. So these are the 2 of the ways they like to display a vector. Now there's a third way, and doesn't look like these first 2 methods at all. And that's where they define the magnitude of the vector and then the direction. So if I look at this here, another way to define this vector is the magnitude or the length of the vector and then the angle of the vector. And that's what this problem is. This problem, they've given us the magnitude of a vector and the angle or the direction of the vector, and they want us from there basically rewrite that vector in terms of I and j, where you can think of x and y. And there's a fairly straightforward little formula that we derived in class from the Pythagorean theorem that allows us to do this. So I'm going to say the vector u, you simply take the magnitude for the I part, or we can also think of this as the x part. Take the magnitude times the cosine of the angle, and that becomes the I part of your vector. This, in a sense, is going to become, I could also say it as like the x. And then I need to get the j part of the vector, which is like the y part of my vector. Once again, I take the magnitude, except now I take it times the sine of the angle. So this right here is a very straightforward way to convert a vector from magnitude direction to I and j. So you simply grab your calculator, make sure it's in the degree mode. I'm going to find the cosine of 85 times 7 equals 0.6, if I round to the nearest tenth. And then sine of 85 times 7 6.97, I'll just call it 7j. So the vector with a magnitude of 7, angle of 85 degrees. Now let's see if that makes sense. I always encourage you to sometimes plot these vectors. If I go try and draw the original vector, 85-degree vector, 90 degrees is straight up, 85 is maybe right about here. And if I call this a length of 7, this is saying if you break it down into x and y, x would be like 0.6. And this is around 7. And it sort of makes sense. It looks reasonable. Now, here's a second kind of problem. Number 12 is where they give us the vector v, and it's in the ij form, minus 8I plus 6j. And I want to now take that vector and rewrite it, where I have the magnitude of the vector v and the angle. So this problem, I went from magnitude and angle to the ij. Now I'm going to go the other direction, from ij to magnitude and angle. And the way you do that, just a couple little formulas. Let's look at the magnitude first. The magnitude of a vector is always this equation. It's going to be a square root, and you take the I part of the equation and you square it, and you add to that sort of the y or the j part of the equation squared, and you take the square root of the whole thing. So this is 64 plus 36. Actually, the magnitude of the vector is 10. Now we need to find the angle of the vector. Here's another little formula. Whenever you have an ij vector, the tangent of the angle for that vector, let me write it like this: the y part over the x part. Of course, the y part is the j part, so 6 over -8. Now what I'm really looking for is the angle. So what I do is, I really want to take, since I want to find the angle, since tangent of theta equals 6 over -8, the way to get the actual angle, you could think of us as taking the inverse tangent of both sides, so you end up with theta equals the inverse tangent of 6 over -8. If some of you don't quite get that, think of it like this. Here's what I have. If I want to get theta by itself, it's almost like I need to get rid of the tangent, and the way I do that, I can take the inverse tangent of both sides. The inverse tangent of tangent, those cancel out. I'm left with theta. And then on the right-hand side, that's what I have here. So then you grab your calculator, make sure it's in degree mode. 6 divided by -8. Then I'm going to take the inverse tangent, and I get -36.9 degrees. Now be careful, because whenever you do inverse trig functions, you have to make sure they make sense. You may have to adjust them. This one I think I do, because if I look, I'm going to go plot my original vector. I probably should have done that at the beginning. That original vector, minus 8i, there's minus 8 in the x direction, and 6j. So it's maybe right in here. That's going to be my theta. But what I just did up here, it says the theta is -36.9. Well, that right there is -36.9. So this is one of those problems where when you get like an inverse tangent, it's going to give you an angle only here on the right side of your graph. If your angle is actually on the other side of the graph, you need to add 180 degrees. So really, my actual angle is going to be 180 degrees plus this -36.9. And the actual angle is 143.1 degrees. And that looks about right. So this total angle right here, 143.1 degrees. All right, so that's problem number 12. I'm going to skip 13 because it's a lengthy problem. We'll try and come back to it. Let's start looking at 14 and then 15 through 18 are all the same. Let's look at 14. 14 on the test review says find the angle between two vectors u and v. All right, so I have two vectors. So this is 14 on the review. Vector u is -10i plus 2j. Vector v is I minus 8j. They want me to find the angle between these two vectors. I'm going to go ahead, since I always forget, I'm going to see if I can plot these vectors just to see what the angle between them looks like, so that when I finish the problem, I can see if my answer makes sense. So u is -10i plus 2j. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. So it's a pretty flat vector. So that's like vector u. Vector v is I minus 8j. So I and then 1, 2. There's vector v. So basically I'm trying to find the angle in between these vectors. And the nice thing is there's an actual formula, and this will be on the back of the test, and it's also on the back of the study guide. And it says the cosine of the angle between two vectors is equal to, in our case, the dot product of the two vectors over the magnitude of the vectors multiplied together. So if you remember, dot product of two vectors is you multiply the x parts and then you add them to the multiplication of the y parts. So minus 10 times 1, those are the x parts of the two vectors. The y parts, 2 times negative 8. Negative 10 minus 16. Looks like the dot product is negative 26. Now I need to know the magnitudes. The magnitude of u, we've gone over the formula for the magnitude. It's always the square root. And you square the x part and the y part. Looks like our magnitude of u is square root of 1 over 4. Magnitude of v, square the x part and you square the y part. All right, so now let's plug them into this equation. Cosine of theta is the dot product is minus 26 square root of 104 times the square root of 65. Grab your calculator, do this calculation. Like negative 0.316. So once again, if I want the angle, I have to take the inverse cosine of negative 0.316. So I grab my calculator, and it says 108.4 degrees. And if you look at my picture, you know the two axes make 90 degrees, and it's a little bit on either side, so 108 degrees looks pretty reasonable actually. Let's go on. 15 through 18 are all the same. Let's just do one of these, maybe two of them. These are the problems where you're given two vectors and you're asked to determine whether the vectors are orthogonal, which means perpendicular, or whether they're parallel or neither. And as it turns out, if they happen to be parallel, then they ask you to determine which direction. Are they the two vectors going in the same direction or opposite directions? So once again, we're going to use this equation right here. Because what happens is, if we find the angle between two vectors and the angle is 90 degrees, then we know they're orthogonal. Or if we go here and we find the angle is 0 degrees or 180 degrees, then we know they're going to be parallel. So the two vectors for problem 15, now we got the pointy bracket, so it's 2, 6, and -1, -3. So I'm simply going to plug those in to my equation. The dot product is at the top, so 2 times -1, 6 times -3, And then now, in the bottom are the magnitudes. This first vector, 2 squared is 4, 6 squared is 36. For the second vector, negative 1 squared is 1, negative 3 squared is 9. So basically I have negative 20 over square root of 40 times the square root of 10. So let's crunch this on my calculator, see what happens. Ends up equaling negative 1. So basically, if I want to find the angle, I take the inverse cosine, and the inverse cosine of negative 1 is 180 degrees. That means these two vectors go in opposite directions, but they are parallel. So my answer would be those answers are parallel, but opposite directions. Let's do one more. How about number 16? Once again, they've given us two vectors. In this case, it's the vector 2, 3, and the vector 6, negative 4. And they want to know, are these two vectors orthogonal, parallel, or neither? Same equation. We're going to take the dot product at the top. So 2 times 6 is 12, plus 3 times negative 4. Now you know what? I can go ahead and calculate the bottom of the denominator, but I don't even need to, because I can see right now, you know what my dot product is going to equal? 12 plus negative 12. It's going to be 0, so 0 over anything is 0. I can actually stop right now and say, for those two vectors, the cosine of the angle between them is 0. And if I try and solve for that, what do I get? I get the angle of 90 degrees, which means those two vectors are orthogonal. All right, not too hard. Let's keep going on. Let me check how much video time I have left. I think this video runs 45 minutes. I got 23 minutes left, so about halfway. Let's talk about polar coordinates, because they're actually pretty similar to vectors. So now I'm looking at problems. I'm going to look at problems 20 and 21. All right, polar coordinates. It's like another way to express, we have rectangular coordinates, which is what we're used to using, which is like our traditional X and Y. But now we have polar coordinates, which are two numbers, but the first number represents R. R is like the length. And theta is like the direction. So for example, number 20, convert the polar coordinate 6. Now notice here, I think for the first time, we're back to having an angle, because this is the angle. It's in radians. Once you see the pi, you know you're in radians. And 6 is like the R, which is going to be the length or the distance. So there's a polar coordinate, and we want to convert that to write it in rectangular coordinates. Now if I go graph this polar coordinate, basically it's saying go to the angle 5 pi over 4. I know pi is over here, so 5 pi over 4 is right there, and I'll just write the 6 to indicate the length of 6. So what I want to do now is I'm going to find that point in rectangular coordinates, like x, y. The nice thing is we have a couple nice formulas. X equals r cosine of theta. So if you have the polar coordinates r and the angle theta, x equals r cosine theta, y equals r sine theta. Pretty straightforward. So for our problem, r is 6, cosine of 5 pi over 4, y is 6 times the sine, 5 pi over 4. So please make sure your calculator is in the radian mode. So I'm going to take the cosine of 5 pi over 4, 5 times pi divided by 4. I'm going to take the cosine times 6, negative 4.2, and then for the y, 5 times pi divided by 4 equals the sine times 6. So it's basically saying, if I convert those polar coordinates to rectangular coordinates, is negative 4.2, negative 4.2. Now let's go the other direction. Problem 21 gives us some rectangular coordinates and says, how about converting these into polar coordinates? So it says, here's some rectangular coordinates, -2, -3. What would that be as polar coordinate? Just to make sure, when I'm all done, it makes sense. -2, -3. Looks something like this, except now I want to express this in terms of polar coordinates, r and theta. Once again, we have some formulas, and you're going to see these are very similar to formulas we used when we were doing math with vectors. The length of r, the square root, the x part plus the y value squared. -2 squared is 4, -2 squared is 9. Looks like if I write that as a decimal, just to get an idea, the distance or the length around 3.6. Now, what's the angle going to be? You We've seen this before. Tangent of theta, we can think of as y over x. In our case, minus 3 over minus 2. 3/2. Now, if I want to know theta, then I'm going to take the inverse tangent of 3/2. So I grab my calculator, inverse tangent, and I'm leaving my calculator in radians because these polar coordinates are in radians. So make sure you're in radians. Inverse tangent . 0.98 radians. Now you think about that. That's definitely not this angle. Where is 0.98 radians? Well, pi over 2 1.6. 1.6 is here. Now this is one of those things where what's happened is we've got the other side. That distance right there is 0.98 radians. So how do I get this angle over here? That distance is pi. So the angle I really want is pi plus 0.98. So the angle is 3.1. I'll put radians here just to be clear. And just for fun, as a check, let's figure out what that would be in degrees, if it makes sense. Remember how to convert from radians to degrees? There are pi radians, 180 degrees. Just for fun, divide by pi times 176.4 degrees. Sounds about right. All right. Now, let's go ahead and next, maybe we'll talk about these law of cosines and law of sine problems. The law of sines is very simple. If you have a triangle ABC, and the sides are just the lowercase letters, law of sines, very easy to remember. Sine of A over A has to equal sine of B over B has to equal sine of C over C. So I don't have time to go over it now, but basically, then the law of cosines, which I will give you on the test, one of the laws of cosines, maybe for angle A, I'll give it to you. So A squared equals B squared plus C squared minus 2BC . So this one is the law of cosines. Basically, if you're given a triangle, you just see which of these laws you can use and go ahead and use it. Now I'm warning you, when you do use law of sines, there's this ambiguous case, but I'm pretty nice to you on the test. If there's a chance to have a second triangle on the test, then I will ask for it. If it doesn't say anything about a second triangle, then you can assume there's no second triangle. So for instance, if I look at problem 1 briefly, they give me angle A of 50 degrees. They give me angle C of 30 degrees. And they said the length of side A is 10. So here's a case where I have an angle and a side, the same letter A and A, and then an angle C. For that kind of problem, the easiest method is always using law of sines. What I'm going to do is I'm going to say sine of A over A equals the sine of C over C. And I know those three things, so that equation will allow me to figure out the length C. So if we wrote it, C would be equal to A times sine of C over sine of A. A is 10, sine of C, which is sine of 30 degrees, over the sine of A. So if I grab my calculator, sine divided by 50, sine. Oh, I'm not in degrees. Gotta remember, gotta be in degrees. Try that again. 30 degrees sine divided by 50 degrees sine times 10, 6.52. About 6.5. Now what am I missing? I've got my angles A and C. I'm missing angle B. Now actually that's very easy to calculate, because when you have two angles, you know all three angles have to add up to be 180. So I can take 180 minus angle A, which is 50 degrees, minus angle C, which is 30 degrees. So angle B is actually 100 degrees. So what's left? I got three angles. I know side A and C. I need side B. How about, I'll say sine A over A is equal to sine B over B. So A is 50 degrees, and it is 10 long. B is 100 degrees. And we don't know, we're going to find the length of B. Just because I'm running out of paper, I'm going to go ahead and do this calculation. It's going to end up being the sine of 100 divided by the sine of 50 times 10 12.8. So now I have found all 6 parts of the triangle. The 3 angles A, B, C, and the 3 sides, small a, small b, small c. Let me quickly do a law of cosines problem, and then we're going to have to stop. I won't have time to do any conic sections today. Maybe next time. If I look at problem 7 quickly, it's another ABC triangle. And they say angle B is 77 degrees. And then they give me side A is 5. Side C is 8. If you try to use law of sines here, it would not work. You have to use law of cosines. So for this one, my law of cosines is going to be b squared equals a squared plus c squared minus 2ac cosine of b. This is going to allow me to calculate the length of the side b. So b squared equals a squared is 5 squared, c is 8, so 8 squared, minus 2 times 5 times 8, cosine 77 degrees. So if I do that calculation and take the square root, I'm going to get b. So 77, make sure I'm in degrees, cosine 5 1/8 40 times 80 plus 64 plus 25. Take the square root. 8.4 is b. Actually, this is one, I think, problem 7. I may have put the wrong answer on the answer key, which you need to fix. Let's see how this works out. Now, let's go find angle A. Safest thing is, if you're going to use the law of cosines, and you don't want to mess up, finish with law of cosines. So a squared equals b squared plus c squared minus 2bc cosine of A. I know everything here but the angle A. So cosine of A is going to be a squared minus b squared minus c squared over negative 2bc. So I plug all the numbers in. A is 5, so 5 squared minus b is 8.4 squared minus c, which is 8 squared, all over negative 2 times b, which is 8.4 times c, which is 8. Wow. Let's see if I can calculate this. So 25 minus 8.4 squared minus 64 . Now on the bottom, what's this, 32 times 16? So divided by 32 divided by 16. By the time you get done, it's actually a positive number, 0.213. So to get A, I need to take the inverse cosine of 0.213. See how that looks. $77.6. Hope I didn't make any math errors, but now once I have angle A at 77.6, then I can simply say angle C is 180 degrees minus angle A minus angle B. And I'm worried because I must have made a math error in here. Well, I'm running out of time. I have to get to this class I have something for tonight. So anyway, sorry about number 7. The method is correct. Maybe you saw my math error. I'll have to go back and check it myself. So that'll be it for now.